So hi everyone, we're continuing with our series of cluster analysis and we have done the hierarchical cluster analysis in my earlier video lecture. If you haven't watched that, I request you to please watch it because that is going to act as a guideline to proceed with the next step. So the next step now is to go up with the k-means cluster analysis. So it's called k-means because k here is the number of clusters which you are looking for, guided by your research question, and then each case or each individual gets assigned to a cluster for which its distance to the cluster mean is the smallest. So this is how this cluster analysis got the name k-means cluster analysis. I'm going to elaborate on what exactly is k-means. Okay, so k-means cluster analysis works by partitioning the data into user-specified number of clusters and then iteratively reassigning observations to the clusters until some numerical criteria is met. Now that criteria specifies a goal related to minimizing the distance of observations from one another within a cluster and maximizing the distance of those observations from other observations in other clusters. So that is the maximization of distance between the clusters. So this optimizing procedure allows you to reassign observations based on the goal of creating the most distinct clusters. So the advantages of this cluster analysis over hierarchical cluster analysis is that firstly, it is suitable for a large data set. So hierarchical cluster analysis, as you saw that, it got cumbersome when we had a big data set. So it's good for a moderately sized data set. And then the results in the k-means cluster analysis are less susceptible to the outliers. And it's clearly, it's a better procedure. So the only thing is that now also you have to ensure that what all indicators you're going to take to make the clusters should be metric. Metric means either it should be continuous data or interval data. Okay. And it's always good to do hierarchical cluster analysis first. And then on the basis of that, you arrive at a number. So basically in our case, we arrived at that, okay, 4 clusters is the optimal solution. So that 4 cluster is going to guide us now, okay, in doing this k-means cluster analysis. Okay, so whatever I just spoke might sound very, very heavy to you. So I'm going to explain you in a better fashion now. Now look at this diagram. So what I've done over here is each of these strands can be imagined as clusters. Say cluster 1, cluster 2, cluster 3, cluster 4. And say we're having just 3 variables. Okay, so I've written the name IV1, IV2, IV3. Okay, so I have 3 variables which are responsible for putting these people into either cluster 1, cluster 2, cluster 3 or cluster 4. Please don't take it as there are only 3 people. There are many people. Of course, my drawing skills could not incorporate those many people. So imagine that there are lots of people as cases or individuals. So in statistics, we call them cases or individuals, which are to be classified into different clusters such that there is maximum homogeneity within a cluster and maximum heterogeneity between 2 clusters. I have elaborated on this concept in my, I think, first video lecture on hierarchical cluster analysis. So I request you to please watch that. Okay, now imagine that each of these clusters appear as a pole. Okay, so you can look at this as a pole, and then on each of these poles, there you can see that each independent variable, say the independent variable 1, or I'm calling it independent variable, but it's not an independent variable, it's just a variable. Okay, so in cluster analysis, there's no such concept of independent or dependent variable. So it's just IV1, let it be. So for IV1, for each of the clusters, I will have a mean score on it. Let's say we're continuing with the same data set. So this is my data set where I have marketing survey, and here people have rated this product on several attributes, as you can see. So we had taken the variables as product quality and then technical support, sales force image, new products, and delivery speed. Now imagine that For each of these variables where consumers or where cases or where individuals are putting a score on them, so these are their scores, on the basis of the scores given by all the individuals, on say the attribute 1, there is a mean calculated for each of the clusters. So in cluster 1, the attribute 1 has this mean. In cluster 2, this attribute 1, orange colored, has this mean, which is smaller. Okay, so maybe this cluster has rated that product on an average relatively lower on this attribute. Then cluster 3 has a large mean on this attribute. Cluster 4 has moderate mean on this attribute. Likewise, I have an attribute 2, and for that attribute, I have cluster 1 ka mean, cluster 2 mean, cluster 3 mean, and cluster 4 mean. Okay. Likewise, for attribute 3 or variable 3, I have a mean on each of the clusters. Now, what happens in k-means cluster analysis is that this cluster analysis will come up with this diagram already using a clustering algorithm. It's going to compute these cluster means, also called as the initial seeds or initial cluster centers. On the basis of these centers, we see that on the basis of the distance, a distance is calculated now. So let's say for individual 1, I will calculate the distance between his score on attribute 1 or variable 1 and the mean score on each of the clusters. Now, wherever this distance is the smallest, that person will get assigned to that cluster. Okay. Likewise, I'm going to repeat it for all the people in my sample. I will assign all of them to some cluster depending upon what is the distance between their score and the mean score in each cluster. Okay. Mind it, this is just one stage. So in your stage 1, some mean was computed for each cluster on all independent variables. Then we found the distance between each individual score and the mean score and put that individual in that cluster. Okay. So after stage 1, when everyone is assigned to respective clusters, these means are recomputed. Okay. So the clustering algorithm again computes some new means on each of the clusters. Then on the basis of those new means, again the reassignment takes place. So I'm going to reassign some individuals again. It's like a reshuffling. Some individual might stay with that cluster again or might move to another cluster depending upon the distance again. Okay. So this reshuffling continues and I have my second stage completed. You see that? Now after second stage also, the means again might get recomputed. Again, reassignment will take place. Again, people will get assigned to a different cluster. And when would the process stop? The process stops when the change in the cluster means is reduced to 0. That means from say stage 3 to 4, the mean on cluster 1 changed from 3.6 to only 3.6. So it remained 3.6 in the next stage. That means my assignment in the earlier stage continues to hold. Okay. So that means the change in 2 stages, okay, the change of means in 2 stages is 0. That's what I'm saying. So when the change is 0, it is actually the stage where I need not reshuffle people again. I am going to stop my analysis and that's how I will arrive at a final cluster solution. Okay, that final cluster solution will be characterized by, again, each of these 4 poles acting like 4 clusters, each of the clusters having a mean of each variable, and then these mean scores will allow us to interpret that, okay, what kind of cluster is this? Is this the cluster who rated me very highly on say product quality? Okay, so let me, or maybe if this is the cluster who rated me very little on product quality, so I need to focus on this cluster in order to better their experience with respect to the product quality as a marketing person. Okay, so that's how the cluster analysis proceeds. Now let's go ahead with our data. Okay, you have to ensure that ID is string by going to the type and putting a string here. Okay, so this is how, so your ID variable is the unique identifier which will allow you to classify people. So that's very important. In cross-sectional data, Please be wary of this. Okay, so we got to analyze, and then I'm going to go to classify k-means cluster. So put your ID variable in label cases by, and all the independent variables, or I should say just the variables on the basis of which you're making clusters in the variables list. So I'm continuing with the same variables 6, 8, 12, and 15 and 18. Number of clusters. So this particular number is guided from the number which you arrived at in hierarchical cluster analysis, say 4. Okay, so because we arrived at that 4 cluster solution is an optimal one, so I'm going to continue with that 4. Method is iterate and classify. Go to iterate and keep it at default. So maximum iterations 10. Save. I want to save cluster membership. Options. Tick everything from here, and missing values exclude cases list-wise. Okay. Continue and click OK. The moment you click OK, you will have such an output. Okay. So in this lecture, we're going to understand half of the output, and half of the output we'll explore in the next lecture. Okay. So starting with the first table as the initial cluster centers. Now, if you understood the process, which I just explained you using this, the interpretations are nothing now. They're absolutely easy. So what are these initial cluster centers? Each of these are your poles. You see 1, 2, 3, and 4. And each of these variables are like these circles. You see this? These are the means on each of the poles. And that's what these are. Okay. So these initial cluster centers offer the K centers. Mind it, K. K means 4. Okay. So these are the 4 cluster solutions, right? So K centers which serve as initial starting point, as each case gets assigned to the closest cluster based on its distance from the mean or the cluster center. So these are the means, which are K means. K means, K ka matlab hai 4, that is 4 cluster solution, 1, 2, 3, 4. And means means ka matlab hai these are the average values. Okay. It's nothing but the mean response for each question or attribute in the respective cluster. You see this? For cluster 1, my x6 variable has a cluster mean 6.7. That means this is the mean score on this independent variable in cluster 1. Likewise, 3 is the mean score on the attribute technical support in cluster 1. And so forth. You can go on interpreting them. So you see that product quality is rated highly in cluster 1 on an average, followed by cluster 1, cluster 2, and cluster 4. Okay. Mind it, this is your stage 1. It is your initial cluster center. And I taught you this procedure is an optimizing procedure. So this assignment is going to continue as we recompute the cluster mean at each stage. Okay. So K-means cluster analysis is an optimizing procedure such that it's going to maximize homogeneity within the cluster and maximize heterogeneity between the clusters. Okay. So these are my initial cluster centers. Now I have my iteration history. Okay. So K-means clustering happens iteratively. Already explained. That is, you start with an initial set of centers, then modify these centers until the change between the 2 iterations is small enough, or I should say nearly 0. So this is your iteration 1, 2, 3, 4, 5. These are your cluster centers के changes. Mind it, ये आपके cluster centers नहीं है. These are the changes in cluster centers. For example, in iteration 1, you have 2.353 as the change in cluster center from iteration 0. 0 का तो कोई मतलब ही नहीं है. So let's look at iteration 2, for example. Okay. So iteration 2 में, what we saw was that my cluster mean changed by 0.316 in cluster 1. Okay. So in cluster 1, okay, your cluster mean changed by 0.316 in iteration 2. Then in iteration 3, it changed by 0.119. Then in iteration 4, it changed by 0.154. Then in iteration 5, it reduced to 0. That means in each of my iterations, the means were getting recomputed, and those means were actually changing. So that change is now computed in this table. जब मेरा change nearly 0 है, that means at this stage, there is no considerable change in the cluster reassignment. So whatever assignment has happened up until stage 5 is your final assignment. इसके beyond अगर आप जाओगे, you're going to experience the same cluster mean. तभी तो 0 लिखा है यहाँ पे. Same cluster mean मतलब same assignment. Okay, so convergence in my model is achieved due to no or small change in cluster centers. The maximum absolute coordinate change for any cluster center is 0. Obviously, maximum change 0 ही आ सकता है. The current iteration is 5. So basically, I say that my cluster analysis converged at iteration 5. Okay, so that is something I have explained you now. Now let's move on to cluster membership. So cluster membership tells you that which case gets assigned to which cluster. Okay, so your case number 1, that means your individual one, who is represented by an ID variable that has a value 1, gets assigned to the cluster 1 such that the distance of this individual, okay, the distance of this individual from that particular cluster's mean is 2.374. Okay, ये on an average है, ऐसा नहीं है कि ये एक independent variable के लिए है अब. Okay, so this is like on an average. इस individual के scores, fine, using the clustering algorithm obviously, इस individual के score were differing from cluster 1 का mean by this distance. That means I assign my individual one in cluster 1. Likewise, my case number 2, characterized by ID variable, that is number 2, gets assigned to cluster 1 as the distance is 2.1. Likewise, my third person is getting assigned to cluster 3. My fifth person is getting assigned to cluster 1. And this process is going to continue till all the 100 cases are classified in a particular cluster, depending upon their distances from the cluster mean. So that's all about today's lecture video. I am going to explore the further 2 very important tables in the next video lecture. And for now, you can see that in cluster 1, we have 27 people. So if you make a frequency count of this column, ठीक है, आप इस कॉलम का फ्रीक्वेंसी काउंट करो कि 1 कहाँ कहाँ लिखा है, फॉर एग्जाम्पल. सो 1 2 3 4 5 एंड सो फोर्थ. सो दैट वुड गिव यू द फ्रीक्वेंसी और द नंबर ऑफ पीपल इन cluster 1. That is 27. In cluster 2, I have 17. In cluster 3, I have 30. And in cluster 4, I have 26. Each person gets assigned to a cluster such that my sample exhausts to 100. So that's all about today's lecture. I'm going to explore these 2 very important tables in the next video lecture. Thank you for watching the video.